Okay guys, here we're going to be looking at setting up and solving systems of equations using verbal models, and so kind of the process that goes behind that and some steps that you can take to always ensure that you can set up and define your variables in your system. So let's go ahead and take a look at this situation here, and then I'll kind of break down how I approach, say, a verbal model problem in the first place. So we say that a total of $24,000 is invested in two corporate bonds that pay 3.5% and 5% simple interest. So remember that simple interest, just the formula there, is the rate times the amount there. It would give you some percentage of the total amount, and that would just be the interest that you get. It says the investor wants an annual interest income of $930 from the investments. What amount should be invested at each rate? And so with respect to solving systems of equations from verbal models, I'm going to make sure that we write a few things here that are just best practice. But the first thing is this: identify the variables. Let me put in a 1 here. So steps to approaching verbal model systems problems. I think the very first thing I always want us to do is identify the unknowns in the problem. So the unknowns, these will be represented by variables. Okay, and of course we would represent unknowns by variables. In this case up here, when we say looking at this problem, what I can tell you is that the unknowns are typically listed in the last sentence. And so it's not always the case, but when I read this it says what amount should be invested in each rate. So when we say, well, at each rate, well, how many rates were there? There were two rates, 3.5% and 5%. So the very first thing we're going to do here is we're going to define our variables, and this is a necessity in every single instance. So I'm going to say because there were two rates, I'm going to define two unknowns, x and y, and they represent the amount that I invest at each rate. So we're going to have a number of something here, and in terms of number of dollars is what we're going to be using here. We say number of dollars, and we say at each rate. So we say at 3.5% and then at 5% respectively. So by defining these variables, what we're going to do now is use these relationships that were kind of told to us in the problem to set up some relationships between x and y. And also because we have two variables here, we're going to want to set up a system that has exactly two equations if at all possible. So reading back through this, in terms of setting up your equations, one piece of advice that I'm going to give you is this: you want to look at, say, units and what you're talking about in terms of the numbers here. So in terms of, say, $24,000, this represented a total amount here, whereas $930, that's in dollars, but that represents interest. And so we're going to write a couple of equations here that represent the different parts of the problem. So for part 2 here, we say write equations that represent the different relationships in the problem. So in this case, we're going to have, let's say, often we have a quote-unquote totals equation. Okay, so that's just kind of a side note there that we have a totals equation. But when you look through this here, one thing that I want you to keep in mind is this: we're saying that x is the number of dollars in the first account and y is the number of dollars in the second account. Well, they tell us that we have a total of, in this case, $24,000 with which to work. So in terms of our system, we would say, well, how could I write an expression in terms of x and y that represents their total? We could just add these together. And so what we're really saying is the number of dollars in the first account plus the number of dollars in the second account is our total amount of money in the whole system here, in the whole investment. Now the other part of this was that it had two interest rates, 3.5% and 5% at simple interest, and the investor wants to earn an annual interest income of $930 from the investment. So as you read through this here, we can kind of look at the first equation as our totals equation. The second equation that we're going to write here pertains to the interest amount. And so when we say, well, how do I calculate my interest? Remember that to find the percentage of a number, we just take the rate times that number. But we could say, well, how much interest did I earn on the first account? Well, it would be 3.5% of whatever you invested. And so because we're going to do 3.5% of x, then we're going to say, well, then the amount that I earned in interest is 0.035x. And then I could find 5% of what I invest at y. If I were to add the interest from the first account to the interest of the second account, I would have the interest overall. And so I'm confident that this is our system here because I don't see any other variable relationships up here, but also because I have only two unknowns, I likely had two equations. So looking at this here, what we're going to do is we're just going to go ahead and solve it. And because it looks like how it looks here, I'm going to shift the decimal 3 times to the right on the bottom equation on all of my expressions. And so that's tantamount to taking everything down here times 100. Or 1,000 really. So if we're going to take everything times 1,000, we would get our first equation, x plus y still equals 24 with 1, 2, 3 zeros. But our second equation would become 35x's plus, keep in mind this would be a 50y, and then we get 930 with 1, 2, 3 additional zeros after it. So to solve this, I might elect to do it by the elimination method. And so because I'm going to use the elimination method here, I'll eliminate my x's. I'll take everything in the first equation times negative 35. So here's where it's going to be important. We actually have our calculator out to help us with this work here. But we are going to, say we get negative 35x minus 35y equals, now I need to take negative 35, so negative 35 times 24 with 1, 2, 3 zeros after it. And so I get this number right here, negative 84 with 4 zeros. So I get negative 8, 4, 1, 2, 3, 4 zeros here. And this is going to be added to 35x plus 50y's equals 93 with 1, 2, 3, 4 zeros after it. So elimination method means that we're going to eliminate our x's here. We're left with 15 total y's, and in this particular instance, what I'm going to do is I'm going to add this to our 93 with 4 zeros after it here, 93000. And what I find out is that 15y's equals 90 with 3 zeros, or 9 with 4 zeros after it. So we'll go ahead and divide by 15 here. What that's going to do is it's going to tell us our y value. But see, since we're doing an application problem, or at least a word problem in this case, we're going to actually want to take the time to interpret what we just discovered. So what I've just discovered then is this. If y equals 6,000, then in the context of the problem, then we would conclude that we should invest $6,000 at the 5% rate. Now, we know that we had a total of $24,000, so we could go back and solve for now how many we invested at the other rate, x, but I would choose to say plug it into this first equation here where we have a little bit nicer coefficients. So we're going to put in our 6,000, we're going to substitute that in for y, and by subtracting 6,000 from both sides, we could come to the conclusion that 24,000 minus 6,000 would be 18,000. So we get this right here. So to finish this off, there are a couple things that I would ask that you write. First of all, that our solution, we did get a solution here, is written as an ordered pair. So we say that the solution occurs at 18,000 comma 6,000. When x is 18,000, when y is 6,000, this set of equations are all satisfied. And then to top it off, we actually want to write a conclusion statement here. And so you're actually going to do this here. We would say the amount invested at the 5% rate, 3.5% rate is, and that was our x variable, so we'd say 18,000, and we wanted to label that, so I put the $sign on it, and the amount invested at the 5% rate is $6,000. Okay. So this is a pretty good example of what it might look like if you approached a word problem here. You would identify the unknowns, and these are going to be represented by variables, and so we could often find that in the last sentence. We're going to write our equations that represent the different relationships in the problem. Often we do have a totals equation, and then to make these last amendments here, I suppose that what we want to do next is solve the system of equations. So solve the system of equations using an appropriate method, and then write a conclusion sentence that states your results within the context of the problem. So we're going to do another one now, and we are going to use these 4 steps here, kind of using our context clues as we put it together. But this next one here is another finance problem. I'll have you look at it with me. It says that a small corporation borrowed $775,000 to expand its clothing line. Some of the money was borrowed at 7%, some at 9%, and some at 10%. How much was borrowed at each rate when the annual interest owed is $67,500, and the amount borrowed at 8% was 4 times the amount borrowed at 10%? Whew. Well, first things first, we want to define our variables. It's the first step we always want to carry out here. So I can't promise you that it's always there, but if you read the last sentence, usually it's going to ask you to go find something. So this says how much was borrowed at each rate. Well, in terms of how many rates there were, I recognize that there were 3 rates here, 7, 9, and 10%. So the very first thing we're going to do is we're going to say let x equal, let y equal, let me fix those equal signs, they drive me nuts, equal, y equal, and z equal the number of something. And because we're talking about an amount invested, then we're saying the number of dollars at each rate. So the number of dollars, and we'll say at, kind of cheating here, And our three rates respectively are 7%, 9%, and 10%. Now, you don't have to put them in this order, but I recommend doing so because that's typically the order in which they talk about these three accounts in the problem. So first things first, if we've defined our variables, then the next thing we want to do is set up some equations, probably three equations here since we have three unknowns, that represent the relationships we see up here. So in terms of totals, do we see any numbers up here that would represent a total amount of, well, dollars, where we say that the small corporation borrowed $775,000. That is the total number right here. So with respect to our equations, let's write a totals equation, if we can come up with the totals equation here. And so we would say that the total of the three amounts here would be x plus y plus z, and we know with respect to this investment here, it comes out to be 775 with three zeros after it. Don't write the comma, it'll just confuse you. Now when they say some of the money was borrowed at 7, 9, and 10%, and then they go on to tell us that we have excuse me, they have to pay $67,500 in interest. Well, we need an interest equation. And thinking about simple interest from our last problem where we had two unknowns, we could see that this was really just finding a percentage of the amount invested at each account. So we have 7% interest of every dollar that we invested there, plus 9% of every dollar that we invested at Y, plus 10% of every dollar that we invest in the Z account here. This should come out to be a total amount of interest that is equal in amount to $67,500. So we get that in here. And then the last equation you might recognize came from this relationship down here. It says, oh, and by the way, the amount borrowed at 8% was 4 times the amount at 10%. So in terms of this being a verbal model, let's piece together what we see here. We say the amount borrowed at 8%. What variable are we using to represent the amount borrowed at 8%? And you know what? Actually, I'm going to say that this is 7% here. Sorry, typo. But we say 7%. Let's put that right here. We would say that's our x. So we say x is really the amount borrowed there, and we say x was, or x equals 4 times the amount borrowed at 10%. Well, that would be 4 times z. Okay, and so let's do this. Actually, this is the 9%. Sorry to confuse everybody here. I'm pretty sure that I set this up with this being the 9. So this should be a 9% here, which means we're going to get the amount borrowed at 9%, which is y, was or equals 4 times the amount borrowed at 10%. This is going to be y equals 4z. And so we get this third equation here, y equals 4z. And I don't know what I would call this. It's just a relatable or a relation between the amount invested at 9 and 10% or borrowed at 9 and 10%. So the very first thing I'm going to tell you before we solve this system is essentially this. We want to get this last equation so that all the variables are on the left and all the constants are on the right. And we also want to eliminate the decimals on this equation here. So I noticed that if I move my decimal twice to the right on all of these values here, or essentially multiply it all by 100, then I would have an equation that has just integers. So let's go ahead and do this. We say x plus y plus z is 775,000. Our next equation would be 7x plus 9y plus 10z, and that would be equal to 67500 with 2 more zeros after it. And then our last equation here, if we move everything back over, we would get y minus 4z is actually equal to 0. So using this now, okay, we're going to go solve this system, and the way we're going to do this is we're going to use Gaussian elimination. So Gaussian elimination, well, what is that? That was that idea where we want to make our system have something in a stair-step pattern here so that it has x plus something, y plus something, and then z, and these are all equal to something where all of our leading coefficients of each row are 1, and then we have this stair-step pattern here. So the very first thing we're going to do is we're going to use our elementary row operations to make sure that we get a 1 or a leading 1 in the top left corner here. Now our 3 row operations are we can switch rows, we can scale a row, which means multiply it by a number, and we can scale a row and add onto another row. Okay, so these steps, they get some taking used to here, but it's a nice formal way of reducing this to something we can solve. So because first things first, I have a 1 in the top left corner, the idea is that we're going to use that 1 to get any x's in the equations underneath it to cancel out. Now the neat thing is I'm already lacking an x down here. So the question is going to be really, what could I take times a positive 1 and then turn around and add to this positive 7 that would get it to cancel out? And what you're going to learn pretty quickly is we're always going to take our leading ones times the opposite of the number I'm trying to cancel out. So what I'm going to tell you here is this. I am interested in taking row 1, or our first equation, and taking it times a negative 7. So So I'm going to multiply this 1 times the opposite of the thing I'm going to cancel, and then I'm going to add it to that thing. So we're going to take -7 times row 1, and we're going to add it to row 2. Now the interesting thing is, using Gaussian elimination, you would think that the first row now would be -7x minus 7y minus 7z equals -7 times this big number, but what we say is that the only row that changes is the row that you're dumping it onto. And so in this case here we have x plus y plus z is still equal to 77500. It's just that 000, sorry. We are going to take -7 times everything in the first row and we're going to add it to the second row. So if I were to say take 1 times -7 and add that to my 7 here, well, first of all, I'd notice that this 7x would become a 0x. And so that cancels out here. Now if I take -7 times my positive 1 here, I would get -7 times 1, which is -7 plus a 9. That would give me -7 plus 9. That's going to give me 2y. Now I want to show you on my calculator here, we're taking the 1 in front of our y times -7 here. So we have 1 times -7 plus the 9 in the second row. So we get 2. So I would recommend actually using your calculator for all of these. We're going to say, well, 1z, if I take 1 times -7, whoops, 1 times -7, and I add that to 10, well, that'd be -7 plus 10, that'd be 3. So I get 3 z's. And then what we're going to do is we're going to take -7, oh my goodness, -7, we're going to take that times 775,000, okay? And then we're going to add that to 675,000. And what I get is 1325000, 1325000. So now I'm going to rewrite my third equation here. The interesting thing is you can see that underneath our leading 1 up here on the first equation, we have nothing left underneath it, which is our primary goal, is to get everything out from underneath our x. Now the next thing to do is to get a 1 here in the next row or second row. Now the way I can do this is I can take this whole row times the reciprocal of 2, which would make it into a 1. Or you could look at that as divide by 2, or what I could do is I could switch rows. So what I'm going to do here is I'm going to switch row 2 with row 3, and the reason why is because I know that if I do this, then this will have a 1 in this second spot. So to rewrite this system here, let's see how small I can rewrite. We have x plus y plus z is still equal to 775,000. The second equation now becomes the third equation and vice versa, so my second equation is now y minus 4z, and that's equal to 0. And then my third equation becomes what my second equation was, which was 2y plus 3z is equal to 1325000. So now working with this, once we get a 1, a leading 1 in the second row here, we're going to use that 1 to kick out anything underneath. And because I know that I want to get rid of a positive 2, here's the rule. We're just going to take row 2, okay, times the opposite of the thing I want to cancel out, which was the positive 2. We're going to take everything in row 2 times a negative 2, and we're going to add that on to row 3 here. And so because I'm operating on row 3, it's a good habit to write that next to row 3. The row that you're affecting here. And so we're going to bring my system back up over here. This means that I didn't do anything to my first row, and nor would I do anything to my first row after I get a leading 1 on it. It's always going to be the same. Now my second row, which is y minus 4z equals 0, because it has a leading 1, it's always going to be the same now. We need to, with our calculators here, take -2 times everything in row 2 and add it to row 3. So we would say -2 times 1 plus 2. I'm getting this here, -2 times 1 here plus this gives us 0. So we know that that happens. If we said -2 times -4, and I add that to 3, then I would get 11. So I know that I have 11 z's remaining here. And then we're going to take -2 times 0 and add it to this. As a matter of fact, it just stays this value right here. And so from here, we could see that the last thing I would want to do is take everything in the last row here times 1/11. Now, that's a really interesting thing to say, that we're going to take everything in the last row times 1/11, because it means the same thing as divide everything by 11. But I would get x plus y plus z equals 775,000. I would get y minus 4z equals 0. And my last equation would just become, well, 1/11 of 11 is 1. So we say z, and then I need to use my calculator here. We're going to take 1325000 and I'm going to divide that by 11, or take it times 1/11th, and I get 12045.55. 12045.55. So at this point, what we can do is we could say, well, now I know my z value here. And so the solution, at the very least, I could tell you is some ordered triple where the z value is 12045.55. Now I got to be honest with you, I didn't intend for this to happen. So maybe back here at this typo, maybe I did mean the 7% account. But that's neither here nor there. What I want to tell you is that now that we know z, we would go plug that back into this second equation right here to find y. So we say y minus 4 times 12045.55. We'll go plug that back in and say it equals 0 here. So I would get, okay, this number times a negative 4. That would be this, and if I were to add that back over to the right side here, basically we would get positive 4 times 12045.55. So, times a negative 1 here. We'll make it positive. Basically 481818.18. So our y value is 48.4818. Let me go back and look. 481818.18. Okay, dollars here, 0.18. And then the last thing we'd want to do is go plug these back into the initial equation, which was x plus y plus z. So we'll put this in for y, plus z, which is 12045.55 here. And that came out to be 775000. So by putting these two numbers together, I'm just going to grab my calculator here. I have my 481818.18 plus 12045.55. If I take that number here, and because I'm saying x plus this number equals this right here, if I subtract this from 775000, 775000 minus my second negative key is my last answer here, I get this right here, 281136. So 281136.27. 281136.27. So within the context of this problem, we have to come to a conclusion here, and so that's where I'm going to actually pull out my text, because I'm just going to write horribly here, but we would say the amounts invested at 7%, 9%, and 10% respectively are, let's see, 281,136.27 dollars, 481818.18 dollars. So let me put a dollars on that. And $12045.55. So that would be our conclusion here, 12045.55. Cheers.